Okay.
Hello everyone, I'm Sai from Mr. Happ's 4th period class, and today I'm going to be going over the average value theorem as it pertains to integrals. So let's first learn the concept. What is the average value theorem? The average value theorem helps us find the average height or average value of a function. If we have a function f of x and this shaded area is the area under the curve of f of x from its bounds a to b, and we create a rectangle that also goes from a to b and has the same area as this shaded region, then the height of this rectangle is equal to the average height of this function. And we can find the height of the rectangle by taking the area of the rectangle and dividing it by the width, correct? And then that helps us derive this formula that tells us that if we have the area under the curve and we divide it by the width of the function, then we can find the height or the average value of the function. So let's jump into an example. Let's say we have the graph y equals x squared, and we want to find the average value, aka average height, from x equals 2 to x equals 7. So this is a reference graph. Our first step is to find the width, so we find delta x. Delta x is equal to the rightmost value of x subtracted by the leftmost value of x. So 7 minus 2 equals 5. Just plug that into the equation. So just 1 over the width and multiply that by our area. Then when you solve that by plugging it into your calculator or just solving it manually, you get 67 over 3. So let's move on to some more examples. Let's say our function is f of x is equal to sine of x, and our leftmost bound is pi over 12 and our rightmost bound is 3 pi over 4. Our first step is to find the width, correct? Delta x is equal to 3 pi over 4 minus pi over 12, which is equal to 2 pi over 3. We just plug that into the equation. 1 over 2 pi over 3 is just 3 over 2 pi, multiplied by the integral from pi over 12 to 3 pi over 4 of our function sine x dx. Plug that into your calculator, or I guess you could solve it manually, and you get 0.799. Remember, in calculus, we always round to 3 decimal places. On top of that, if you wanted to sketch a graph for this problem, because that might give you a visual representation, then go ahead and do that. I just didn't do that because it doesn't really help me, but if it helps you, then you should do it. Okay, now I'm going to work on a problem with all of you guys. So, in this case, our function is f of x is equal to x plus 12, and our leftmost bound is 1, and our rightmost bound is 4. So our first step is to find delta x. So delta x is equal to our rightmost bound, which is in this case 4, subtracted by our leftmost bound, which in this case is 1, which gives us that delta x is equal to 3. Step 2 just tells us to plug it into our equation, so let's move on to step 3. Now we just plug this into our equation, basically. So we do 1 over our width, so 1 over 3, multiplied by our integral from our leftmost bound, 1, to our rightmost bound, 4, of our function. Okay. Our step number 4 is just to plug this into our calculator or solve it manually. I'm going to show you how to do it on a calculator. This is the calculator. This is a TI-84 Plus, but if you have a TI Inspire, then you could probably solve it the same way. The buttons might be slightly different, like rearranged, but it's still the same process, I believe. So just click Math, and then on the TI-84, you click 9 to get function int, and then you just plug it in. So 1 to 4 of x plus 12 in respect to x. That gives us 43.5 as our area, and we divide that by our width, which is 3, to give us that the height is 14.5. So 43.5 is our area. Area divided by our width, which is 3, is equal to our height, which in this case is 14.5. Okay, let's move on to some common misconceptions and common errors. So our first one is that sometimes people forget that we're looking at a specific area of the function. We have bounds. We use these bounds to find the width, and we also use them to create the integral. So if you don't recognize that, then you're not going to be able to solve these problems. We're basically trying to find the average value of a section of the function, not of the entire function itself. The next common error is that people often don't know how to use their calculator to find the integral. Mr. Happ showed us how to do this in class, and I also showed you how to do it on the TI-84. If you have another calculator, you can look up a video on YouTube on how to solve the integral, but that is really essential to being able to solve these problems, because some of them can be really complicated, like you saw in the second example with the sine. In our third common error slash misconception is that people don't understand how to find the height because the area is not a polygon. For example, this is a curved part of the graph, right? And we do have a width, but people are like, oh, how do I find the area of this, of a curved region, right? We don't know how to do that. But what we're doing is we're just molding this area into a rectangle, correct? And we know how to solve for the height of a rectangle. Just think about it like this. We're taking this whole brown area and we're just like molding it. We're squishing it together to create this rectangle. Then we can use the width and we can find the area, and we can divide the area by the width in order to find the height. And that's equivalent to the average height of our function. So as you can tell, it's really important to have a good conceptual understanding of this concept in order to be able to do it well. So now let's move on to MVT, mean value theorem. Ryan's going to take over, and it should be pretty easy if you understand average value theorem. Hopefully this video helped you, and hopefully Ryan's video helps you as well. Thanks for watching.
Hi, my name is Ryan Kai, and I'll be doing mean value theorem for integrals, and this is just building on top of Sai's presentation. So the concept of the mean value theorem is that if you have an interval from a to b and you have a function f of x and it's continuous, then all this just states is that there has to exist a value c in which that value is the average value, and if you multiply that by the interval b minus a, then that will be equivalent to the integral from a to b of f of x. So let's look at the relation to the mean value theorem. On the top portion, I have the average value theorem and I have the mean value theorem. So now, instead of having f of x in this initial equation, let's replace that with f prime of x. Now, looking at the circled part, what would that equate? Since the antiderivative of f prime of x is f of x, then that is just equal to f of b minus f of a. Now that looks very familiar. And we look back to our mean value theorem, that is just a top portion. So let's replace that. Down here, I have f of prime of c is equivalent to the integral of a to b of f prime of x over b minus a. Now, this is almost exactly like the first equation. However, we can always replace f prime of x with y of x. And if we do that, we get y of c is equivalent to the integral from a to b of y of x over b minus a. And that's just equivalent to the average value theorem. And that is how you prove that it guarantees a value c in the interval. Now let's look at one practice problem where it asks us to find a number c satisfies the mean value theorem from 1 to 4 of the function x squared plus 3x plus 2. Now, to solve this, we first have to know our formula. And this is just 1 over b minus a of the integral a to b of f of x. And that's equivalent to some value f of c. Now, we multiply both sides by b minus a. We'll leave the integral on one side. We have on the other side f of c multiplied by b minus a. Now we just plug in the parts of the problem that we know into this equation. For example, f of x is just x squared plus 3x plus 2. And on the other side, f of c, well, think about that. You just plug c into the equation. So that will be c squared plus 3c plus 2 multiplied by the integral 4 minus 1. We get 99 halves. And that is equivalent to 3c squared plus 9c plus 6. You should get two values. You should get c is equal to 2.593 and c is equal to negative 5.593. Now, the second value, negative 5.593, is crossed out because if we remember our interval, it's from 1 to 4, and negative 5.593 is clearly not in that interval. So only 2.593 works in this situation. So some common mistakes of the mean value theorem is that some students may subtract b from a, and that will be a problem because you'll get a negative number. Thank you.